All right, page 28. So if you haven't done so, I would like you to follow along and enter this in your calculator. Try to, because if you're just sitting there, you might fall asleep on me. Okay. So I'm going to enter this equation into my calculator, and remember, there's no y and x. Like it's actually rare to have y and x, unless it's not a word problem. So when we read, as you're entering this, I'm going to quickly do that. Would you have known that this is a linear? It's not the standard way of stating it, but there's no power of 2 or 3. So this is a linear. Okay, this is linear. It's just x, right? Not x squared. So V is the voltage, and so we use the letter V. H is the hours of radio use. So look at where H is located. It's on the right side, which is the x variable. So x and y. So we know that it's time of use and voltage. Okay. Graph on your calculator. So let's do this. Oh, I just gave it away. A, what type of function? It's linear. Highest power of x is 1. Okay, there we go. Explain, that's how I know. So what voltage is produced after the battery has been used for 3.75 hours? I'm going to do B right there. So they're saying, right, if it's been used 3.75 hours, like what's the voltage? So we got to use second, trace 1, we let x be 3.75. First I have to graph it and make it fit, okay? So let's see, I'm gonna hit graph and see what happens. Don't see a thing. I'm gonna try zoom standard actually first. Zoom 6. Still nothing. I know that my y-intercept is 12.35 and that this is going down, correct? Leading coefficient is negative. So I need to make some changes here. I'm gonna increase my x max. I'm gonna also increase my y max. Maybe zoom fit would have done the trick, to be honest. Well, there it is. I start seeing it, and it's just sloping down very slowly. So I'm going to increase the x max here until I see it touch the x-axis. So what is it, 100? I don't know. Still not. Do we need to go that far? Let's think about it. As you're using your radio, the battery goes down, correct? Less and less voltage, right? One of these. Put your thumb on it. Have you ever been dared to put your thumb on one of these? Go ahead, don't do it. It's fun, actually. So the voltage isn't going to drop just drastically, right? It's not going to, after an hour, stop working. So that's why it's going down slowly. So try to picture the scenario here. Anyways, I think we've got enough to just go second, trace 1, 3.75, and the voltage is 12.23. You got to put the units. It says volts, so you just go with it. The province sometimes has very bizarre units because they try to make it a real life scenario. Just go with what they give you in terms of units. They will give you the units. Okay, C. If the battery must be replaced when the voltage reaches 11.8, how long will the battery last before it must be replaced? In this case, we don't know how long, but we do know the voltage. So when you're given the y value, you just go and enter that into y2. You go second trace 5. So y2 is 11.8. And here we're going to make sure we see where they meet. And they do, right? They do meet. It's probably not the prettiest graph, but it's good enough. The calculator knows where everything is. And so x is equal to 17.74. rounded to 2 hours, right? So from time 0 till where it hits 11.8, this many hours went by, and that's it. D, state the domain and range of this scenario. Use your results in C to answer this. The domain is regarding my time, correct? Because it's the X values. The range is regarding my Y values, which in this case is the voltage. Okay? So you got to keep that in mind. So we go from time 0 when we start, when we just put in the batteries, that's considered time 0. You start using it. When will the time stop? Like after 17.74 hours, right? That's when, in this scenario, the model stops. Like we have to replace it now because otherwise it won't work. For my range, what's the lowest voltage in this case? It is 11.8, right? Because then it has to be replaced. So that's the lowest voltage, and the highest 12.35. Yeah, this one here, because that's my y-intercept. I'm going to write this here. The y-intercept is 0, 12.35. That's straight from the equation right here. They just flipped it on us. Okay, don't let that throw you off. So yes, 12.35 is the highest voltage according to this model. Okay. Boom. Graph this scenario. Graph, not the function. What does it say? Graph this scenario, right? So you don't have to do the whole thing until it reaches the x-intercept, because that would be a long time. Okay. This battery is probably, I'm guessing, 8 years old. And if I measure this with one of my classes, I measure it. It's still like 7 point something volts in it, right? And it starts with 9. So it takes a long time for it to get to 0. So here you go. This is voltage in volts. So have both, okay? And this would be time in, what is it, hours, right? Yeah. So just make sure you have that, and then an appropriate scale. My time stops at 17, so I'm going to go to 20. So 5, 10, 15, 20. So sometimes linear, I don't spend too much time on it because I think it's easy, but it's still, you still got to watch out for, there's no necessarily easy, but it's easier, I would say. So for the voltage, we need to go all the way up to 1235. So let's see here. 2, 4, 6, 8, 10, 12. I think that could work. So I'm just going to label every other one. So it's just up here somewhere. And then it stops at 17. This would be 17.5. So 1774 is just a bit to the right. And then I go and find 11. This is 10 here. 11 would be right there. So 11.8 just there is fine. So this is a weird graph, right? You might think there's something wrong with it. But that would be it. I don't know what my key had. Yeah, my key kind of looks the same. And I'm just missing this here, 12.35 minus 0.031 H. And you're done. So I'm just going to scan this and my key is updated. Yeah, okay. Next one is a linear as well. But we're not going to do it. We're going to go to the next topic. I'm going to stop this video